Welcome to today's explainer, everyone. So, you know that feeling of megalophobia? That kind of innate, overwhelming fear you get when you're looking at massively huge objects? Well, today, we're going to push the absolute boundaries of human imagination and honestly probably trigger that exact fear. We're taking a journey into the deeply, deeply horrifying scale of our universe to analyze an absolute cosmic titan known as Stephenson 218. We're going to break down the physical reality of this stellar behemoth step by step. So get ready to shed all your earthly intuition because we're going to try to actually wrap our minds around a scale that completely defies standard human comprehension.
The human mind is not equipped to comprehend true cosmic scale. There is a reason people say that, It's just true. As humans, we're so used to measuring things in feet or miles or maybe trips around the globe if we're really thinking big. But the universe, it doesn't operate on human terms. When we look out into the deep cosmos, we are forced to confront objects that are so absurdly vast, our brains literally struggle to process the geometry. And this specific star we're analyzing today, it's the absolute ultimate proof of that concept.
Okay, let's dive into this. To truly grasp what we're dealing with, we need a baseline we actually understand, right? Our own sun. When we look up into our sky, we see an absolute titan. It's an unstoppable giant of fire. It provides literally all the heat and light for our entire world. It dictates the orbits of every single planet in our system, and it is so incredibly massive that more than 1 million Earths could fit entirely inside of it. 1 million. In our daily lives, the sun represents the absolute pinnacle of immense, blazing power. We just naturally consider it to be the ceiling of massive objects. So, I want you to hold on to that image of our mighty sun for a second. Because our baseline, well, it's about to be completely shattered.
Because here is the reality check. What's really interesting about this slide is the sheer, incomprehensible difference in size. When you place our blazing baseline next to Stephenson 218, our sun doesn't just look small. It is literally reduced to a microscopic speck of dust. Just imagine that for a second. The anchor of our entire solar system completely dwarfed, rendered practically invisible by comparison. It's a total game changer, right? It immediately illustrates how everything is relative in the cosmos. You think you know what big is until you stand it next to Stephenson 218.
So, where exactly is this thing hiding? You might think it's in some far-off, unreachable galaxy on the absolute outer edges of the observable universe. But nope, it's located deep inside the Scutum Centaurus arm of our very own Milky Way. That's right, this colossal monster is sharing our galactic neighborhood. It's residing right here within our own galaxy, just churning away in the deep cosmos. Grounding ourselves spatially like this is absolutely crucial because it reminds us that these terrifying cosmic scales aren't just abstract mathematical concepts. They are physical realities occupying the exact same galaxy that you and I call home.
Let's look at what we're actually dealing with here. Stephenson 218 is officially classified as a red hypergiant. Now, this is a classification of star so incomprehensibly massive that it pushes traditional models of astrophysics to their absolute breaking point. It's so enormous and so extreme that the traditional equations scientists use to understand stellar evolution literally struggle to contain it. Its physical traits completely challenge human understanding of physics. Honestly, it shouldn't just be called a star. It is a total anomaly. It's a celestial body that forces us to completely rethink the upper limits of how large a star can get before it just tears itself apart.
To truly grasp what that staggering size means in physical space, we're going to run a little thought experiment. I call it the solar system scale test. Imagine, if you will, that we somehow managed to pull this massive red hypergiant out of its home in the Scutum Centaurus arm. Imagine we just drag it all the way over to our local neighborhood, and we drop it dead in the center of our solar system, exactly where our sun currently sits. What actually happens to us? Let's move to and see how this builds. First, it swallows Earth. Instantly. Gone. Then it continues expanding outward, effortlessly swallowing Mars. The edge of this immense star pushes further out into the cold darkness, completely consuming Jupiter, the largest planet in our solar system, without a single trace. It literally just vaporizes it. And finally, the boiling, churning surface of Stephenson 218 pushes all the way out until it reaches the orbit of Saturn. Just take a second to let that horrifying scale sink in. The physical body of this one single star stretches from where our sun is all the way out to the rings of Saturn. It's just mind-blowing. But here's the thing. This titan is not just impressively large. It's dying. Actually, that immense size, It's a direct symptom of its advanced age and its stellar life cycle. Time is literally running out. It's burning through its fuel, expanding outward as it desperately struggles to maintain its own incredibly massive gravity against the outward pressure of its core. There's a deeply unsettling tension here, you know? Something this massive, something this physics-defying, it cannot simply fade quietly into the night. No way. It is headed for an inevitable and extremely violent end. When it finally dies, it's going to result in a hypernova. That's the violent collapse of a massive dying star that triggers one of the most explosive events in the entire cosmos. So the crucial point is this. All of that stellar mass, remember, stretching all the way to what would be Saturn's orbit, will violently collapse in on itself in just a fraction of a second, and then rebound outwards in a catastrophic explosion. The sheer kinetic energy released will be almost unimaginable. We're talking about a true spectacle of cosmic destruction that will send massive shockwaves rippling through our galaxy. Which leaves us with one final, lingering thought. When this Titan finally collapses, will anything in its cosmic neighborhood survive? If a star that absolutely massive unleashes a hypernova, what happens to everything around it in the Scutum Centaurus arm? It's an awe-inspiring, frankly existentially terrifying question to ponder, isn't it? Thank you so much for joining me to explore this cosmic anomaly in today's Explainer. Keep questioning, and as always, keep looking up.